And carbon is 4 valence and chlorine is 7 because we labeled these probably even. Remember, it's 1 valence, 2, skip 3, 4, 5, 6, 7, 8. Column 2 and column 8 won't come up, but we had 4 and 7 valence. So the easiest way to save your pencil is to go 2, 4, 6, and that is an L, not a cloud. And then put the oddball one, this 7th one, toward where you're going to have the bond. Saves a lot of erasing. 2, 4, 6, 7. Oh, there was BH3. Ha! Oh well. So we already did that one. Trigonal planar. So what I have left on 21 is 4 valence from carbon, and I have 4 bonds to complete. So I'm going to use one of them. That's bond 2, 3, 4, and that's a bond. And we're done. And take a moment. Everybody diagrams as an 8. Everyone's happy. Tiniest mental self-test of the week, maybe. You don't have to shout it out if you don't want to. What's that shape? Four bonds and no clouds on the center point is tetrahedral. I don't know if I can get these both in the picture. Anyway, is there something I should repeat on that one? And if you have been paying attention to even those, what, 5 or something that we did, 5 in the examples, you know what? Honestly, I've said all the news I have to say. Keep on going. And I mean, I'm going to keep on helping, but that's all the new information. The rest is just practice. Make the Lewis dot diagram. Count the lone pairs and atoms on the center point, and check your chart. That's the whole thing. It's one of my shortest new pieces of information all year. How about HNO? HNO? In that order, by the way. It's not, the H is not on the O. It's this way. So H is a 1, nitrogen is a 5, and oxygen is a 6. So we get 12 valence electrons. So how about 2, 4? Leaving me 8, and they sure don't go on hydrogen. So 2, 4, 6, 8, maybe to start with. Except nitrogen is not happy because it has 2, 4, 6. It's going to get grabby. It can't grab from H. It's going to grab from O. It doesn't matter which pair you grab because they're not there anyway. So pick a pair. I guess I'll just pick the end, and it puts it in as a bond. And what shape is that? Actually, we did one of these. Remember, that's a cloud. So I don't care if you want to put it as a bar or a cloud. Make up your own mind. But that bar was 2 electrons unbonded, and it is a cloud. And it might be helpful to put it as a cloud on a center point so that you recognize it's that. How about 31? I'm hoping we can speed up a little bit here. P goes in the middle, the H's are arrayed around the outside, and maybe put them like that. You don't have to. I'm not going to argue if you end up with this. Okay. All right. The point is, do you recognize the shape once you got it down? Not could you see the shape coming? And in fact, you'll see that my shape here looks even now, but it ends up being kind of wrong. And I'm just going to leave it like that because my point is you don't have to know what's coming as long as you can do it correctly by the end. So this is not going to be a very good shape to visualize in the end. But I'm going to leave it there because I'm a student and I don't know what that would be. Okay, that's fine. But hydrogen brings in 1 valence electrons, 1. And phosphorus is in our 5 valence column. So I'm going to need 3 for bonding, 1 to make a bond, 2, 3 to make bonds, and that leaves me 2 extra on the phosphorus. And you can put a bar or 2 dots, but I'm going to put a cloud just to try to be a little more visually helpful. And what shape is that, kiddies? Three atoms and 1 cloud on a center point is a tetrahedral, except kind of break off one of them and make it a cloud, and we get trigonal pyramidal. It's a tiny pyramid that has a 3-sided bottom. Oh, I've also learned recently, apparently everybody says it pyramidal, and apparently I am the weird one. Okay, sure. Trigonal pyramidal. And that is so much writing that I get annoyed. And then let's pick something weird. Like 25. SE, you know, I get mixed up and I don't remember where SE is on the chart and how many valence it has. I genuinely don't remember right at the moment. What is it? 6. And it's got 4 CLs around it. Okay. E, CL, 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 CL. And CL, I did remember, but here it is. It's in my halogens, my 7 valence column. So I get 6 and 7, 7, 7, 7. With these ones on the outside, it's probably easier if you'll just put the 7 and leave them if you can. So 2, 4, 6, and 7, and we will repeat that. And a selenium, that is, gets 6, and I need 4 of them for bonding. So 1, 2, 3, 4 for bonding, leaving me 2 more, and the chlorines don't want them. It's going to go on the center point. And that's actually, again, not a very good artistic depiction of the molecule, but we're not asking for that. I'm saying, can you diagram it right and recognize it from the chart when you see it? So I have 4 atoms and 1 cloud on the center point, which is what? Somebody want to shout that out?
Is it the trigonal pyramid thing?
This
No,
one?
that's not right. Never mind.
No, okay. And thank you for helping, and I'm not yelling at you, but notice that that's 3 atoms on 1 cloud.
Yeah,
How many?
no, I know. That's why I said it was right.
So where's 4
It's
atoms on 1
the
cloud?
seesaw, right?
Yeah. Now, I added seesaw because it bugs me. The original person I stole this from had sawhorse, but a sawhorse has 2 legs, right? And a bar. It's hard to do with here like that, right? And this only has like, if you do it like this, here are the legs and here's the bar. but a sawhorse has two legs, and two sets of legs. So that bugs me. So I call it a seesaw, that if you put this down on the ground, this is the bottom on the ground, then this bar here will go ee-er, ee-er. It's a seesaw. And I didn't just make that up. Some people really do call it seesaw. I don't care. Pick a name. But 4 atoms and 1 cloud on a center point. And I like seesaw because I think sawhorse is kind of dumb. I won't mark off for it. I wonder do the British say seesaw? Do they call that child's playground equipment a seesaw? I don't know. They seem to have a different name for everything. They say stuff like, I was on my pedal bike. You mean a bicycle? Yeah. And we're getting oh, you know what? I missed a trick here. You know what? I missed 2 things. I have -1 and -1 on myself. For 22 and 25, I forgot something from last class. Who wants to show off and tell me how I'm wrong?
The resonance or whatever thing.
No, it's not.
right?
It's not redness.
Oh, octet.
Yeah, it's an octet violation because boron does not have 8. It has 6. So this also needs octet violation. And this one, selenium diagrams, has 2, 4, 6, 8, 10, which is an octet violation. So we'll shoehorn that in somewhere here. And I only want to do, I think, a couple more examples because, like I said, I was done with new information in about 5 minutes in this class. It's a matter of practice. Except, and I say this to be helpful, I really do. Every year, when we're in regular school, I would do like 2 or 3 sheets of just Lewis diagrams and then 2 or 3, like 2 sheets of just VSEPR, or by the way, some people call this VSEPR. I know it does not spell that way. So I am a total nerd and I say VSEPR, and I'm probably in the 2% of people that say it that way. If you go to college and they talk about the VSEPR theory, this is what they mean. Oh, by the way, also, just to say this is valence shell electron pair repulsion theory, just meaning that the valence electrons of all these try to get away from each other, which is why this is in a line, because this group is trying to get away from this group as much as possible. Oh, my original point was, if kids complete the homework, then by the time I have a quiz on this stuff, they've done, say, like 80 problems just with even out the shapes, and then like 80 with the shapes, and I still get 5, 6 Fs, and it's because they won't try. Honestly, I genuinely don't even think it's a brain problem. I think it's an effort problem in almost every case. Please do yourself a favor and actually get the point by doing it enough that you go to the point where you say, oh, this is kind of easy. When you say that genuinely to yourself, because you keep getting the right answer and you got the right answer the last 9 times, you're probably right. You're probably done mentally. Just throw in the rest of the answers and be done with it. So let's pick something else that's a little weird, though. 35?
How would you do 39?
39, she says. Oh, sure. We can do that one, too. That one is extra weird. Did you see the little text there? So because xenon is so far down the periodic table, I don't know how they did it. I never looked it up and no one ever told me, but I have seen some diagrams that even though I said they won't come up and so forth, and I don't think they're on any quizzes. The noble gases down here have been forced into some compounds because their outer electrons are so far away from the nucleus in the center that they will react if you push them real hard, I guess. So, all right, fine. Yeah, let's do this. And I don't mean find you, I mean find that that's weird, but here we go. F, 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 F. Now, xenon has 8 valence, and fluorine is 1 column over, it has 7. And with those, it's probably easier, again, if you go 2, 4, 6, and put that 7th one toward the center. I think that was Jessica. Is this working for you so far?
Yes.
Okay, and then xenon has 8, right? And I need to complete 4 bonds, so I'm going to use it 4, doing the bonds. 1, 2, 3, and 4, which leaves 4. And they don't go on fluorine, they go on xenon, so we get there. And I don't want to argue about where the clouds go. Actually, I think they kind of are up and down, but that's not the point. I just ran out of room. So I don't want to argue about where the clouds go on xenon. They just go on xenon somewhere where you can fit them. It's not art class. You're not being asked to memorize that chart. So I just put them somewhere on xenon. And now we have 4 atoms and 2 clouds on my center point.
Is the shape square planar or whatever?
Planar, yeah. 4 atoms and 2 clouds. She's right. Square planar, huh? Because look what you have. You have this octahedral. And so if you break off 2 of them, it doesn't even matter exactly which 2. They're just going to be opposite. The clouds are going to try to get away from each other. So you could pick these 2 or these 2 or these 2. It doesn't matter because there's no top, right? Oh, look, now the clouds are up and down. Now they're left and right. Now they're at a diagonal, right? So there's no top. So just, they could have put the clouds as here. It doesn't matter on this one. I put my clouds on top and bottom. It doesn't matter. But there are 4 atoms and 2 clouds, so that is square planar. There's one more thing to put, though.
Octet violation?
Thank you. That is a big octet violation because xenon has 12. I thought I'd do a few more. We got half an hour. Well, this won't be all period. I keep thinking I'm about done, and then I think of a couple more things I should probably just be helpful with. Like 37, not because it's got a weird shape, but because let's review something else that we did last class. So in fact, we did this problem, but it's been 5 days probably since you did it. Carbon
This one's
is
going to have 2 extra valence electrons, right?
2 extra valent, no. Oh, excuse me, yes, because the -2, you mean?
Yeah.
Yeah. Right, good point. You got me on that. Yeah, you jumped ahead. Good. That's a compliment, not an insult. So carbon has 4, oxygen has 6. It's usually easier if you just go 2, 4, 6 around the edges to get started and leave those if you can. It's usually easier, if you take the extra ones and just pretend they went in the middle, usually. So carbon is not a 4 now, it has 2 extra, it's a 6, and I need 3 bonds, 2, 4, 6. So that works out nicely, except this is not done. And at the moment, pretend I turn this in on a quiz, this is missing 4 things. You didn't name the shape, then the diagram is wrong 3 different ways. The labels and the diagrams are missing. This is a disaster. This is not an F+. This is like an F minus right now. There's a bunch of stuff we're not done with.
So you would have, for this one, you're going to do the Renaissance.
Resonance.
Thingy, right?
Resonance. Right, because carbon diagrams Shh. As 246, it's not going to take it. It's not going to sit still for this. It's going to get grabby. But all the choices to choose one pair from are equal. It has no way to choose between this, this, or this. So pick a spot. In fact, Jessica, you've been speaking up. Do I go left, right, or down?
Right.
Right. Okay. Now I'll pick one off the right, and I'll put it in the middle. Except really, it picked equally from all of them, so it's a resonance structure. Really, it's a 1/3 distributed partial fractional double bond every direction. You don't have to put that in the diagram. I think it's really annoying to have to draw that out all the time. So I will accept resonance structure as the method of telling me, I know it's not really just there. I know it's 1/3 distributed. Now that resonance structure kicks so many butts every year, and I'm begging for questions. Can I explain that again for somebody? And I probably said this before, but also, and I'll say, in a nice tone of voice, but the other thing is, the reason I really do not, I don't cry about kids getting Fs because you have YouTube. YouTube is the biggest thing since books. All you would have to do is put resonance structure into YouTube, and 20 people are trying to tutor you on resonance structures. So there are no excuses. Also, I can try to remember to put my favorite tutors. Did I make a document with my favorite YouTube tutors on Classroom yet? Maybe I didn't. Anybody seen one?
You said you like some people, but you didn't
Yeah.
like put their names down or anything.
Okay.
You said that
Then
in class.
Okay, fine. Good point. So then I can make a materials that is, I recommend like these 5 channels, sort of, and I even have an order from like the guy named Tyler, who just is so helpful. His whole attitude is, okay, today we're going to be doing Lewis structures. So what you're going to need is your periodic table. Now S has 4 valence electrons. And it's really nice if you're starting out that he acts like, I know you don't get it. So we're all going to be very helpful. And he has pieces of paper already done where you don't have to wait for him to write stuff out. And then there are people who act like, so you kind of get this, right? So I'll just go over it again. But if you do kind of get it, that's nice. Because after a while, Tyler that I mentioned is really slow. You're like, yeah, I know, get to the point. So you may want to progress through tutors as you go through a topic, all the way to the lady who just goes bam, 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 bam. She's just charging through it. But if you get it 80%, that's actually kind of nice because you're like, yeah, get to the part that I didn't understand instead of me waiting 6 minutes for you to get there. What else was I thinking of? Let me cheat and look at my answers for another weird one. I was going to do
35.
Oh, 35, were we? Okay, sure. That actually was one of them. SCL6. S goes in the middle. The CLs go around. The outs are arrayed. I like to teach that word, arrayed. A distributed group. Around the outside, is that 6? That is 6. Chlorine has 7. So 2, 4, 6, 7, and do that for all of them. And sulfur is in our 6 valence column. And look how many bonds we need to complete. 6, all needing 1 electron each. How convenient. 1, 2, 3, 4, 5, 6 I used from sulfur. Oh, you know what? We forgot a bunch of stuff on 37. I got myself talking and I forgot. We've got to go back to 37 in a moment. So what's the shape of this? And does it need any additional notes? Oh boy, does it need octet violation. That sulfur diagrams as a Venn diagrams as a 12 valence. Yeah. So what shape is that? 6 atoms and no clouds on a center point. Octahedra. Yes, octahedral. Okay, also, for my math and science people who just like to learn all the little deals, it confused me for years how this was octahedral and there are 6 atoms on the outside, and even if you include the middle one, that's 7. Where's the oct part, right? So in case you care, I'm not going to ask this. Here's why. Pretend this shape is now sitting in front of you, right? It's right there. It's like a foot tall and so forth, and you're going to make a solid out of it. It's sitting on the desk. You could put a triangle piece of wood or plastic or something between here, right, and make a solid side. And then you would need a second one and a third one and a fourth one, and that would complete only the top half. So there are 8 sides, aren't there? There are 8 sides. If you make that a solid, that's why it says oct. It would be an 8-sided solid. And if you paneled up this one, you'd get 1 piece, 2 pieces, and one in the back, 2, 3, and that would be just the top half. And then, well, the bottom you wouldn't do. You'd have a pyramid that's 3-sided, except there's also the bottom. The bottom would also be an upside down pyramid that's 3-sided, and that's why it's trigonal bipyramidal. There are 2 pyramids in there with 3 sides. Anyway, this is octahedral. And we forgot stuff back here. I put resonance structure, and I forgot 2 things. At least one thing. One thing. I forgot -2.
Actually.
What?
Got the shape too.
Oh, I forgot the shape too. Thank you. I knew that. Yes, there was 2 things. You're right. So there are 3 atoms and no clouds on a center point. And I thought I'd do like one more, and we did this one yesterday or last time we were here, but it's weird. And I like to put this one on the quiz because where is it? Didn't I put, is nothing? Here, 20. I like to put 20 on a quiz, I'm telling you now, because it's a little weird. But my defense when kids get it wrong is say, we did that exact problem 3 times. 3 times. I taught it, and then, I taught it directly. You did it with me. So, your excuses are kind of gone. So, O, 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 and we get 6 and 6 and 6. So how about we go 2, 4, 6, 2, 4, 6. That's usually helpful to leave them on the ends if you can. And then I get 6 more, and I got to have 2 bonds. So 2, 4, and I guess the only other place is in the center. And now you could double check, but I should have 6 plus 6 plus 6 is 18. 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay. Except the center oxygen is unhappy, and it has 2, 4, 6 valence. It's not going to sit there and take it. It's not boron. It doesn't get bullied. It's going to get gravity, but the choices to choose from are equally attractive. So it chooses equally. I think last time I went right, so I'm going to go left just to prove I don't care. It doesn't matter. I'm going to borrow one in there. But really, it chose both directions at the same time. This is a half a double bond. That's a half a double bond. This one's sort of half gone. That one's half gone. And it's a resonance structure. And the point of today is, what shape is that, though?
Bent, right?
Yes, 2 atoms and a cloud on the center point, isn't it? The number of bonds in here does not matter. That doesn't change the shape because the bonds aren't wide enough to count for anything. So this is bent. At that point, and we've only got 27 minutes or something, I'm going to count myself as kind of done. So fine. If, you know, ding, that's the end of instruction. You need to complete this, turn it in. But having said that, I don't mind being helpful. If you want to just like hit mute and go do this, that's fine. Does somebody have a request though? Or, you know, I thought I understood number 35, but now I don't, or something. Or even I found a mistake on your answers. That would be helpful if you would do that. If there is one.